Hi guys, today I'm gonna solve the problem to second order ODE with constant coefficients. So here's my question: y double dot minus y dot plus 6y equal to 0. So to solve this equation, we can assume the solution: y equal to a exponential lambda x, right? So what about y prime? Y prime means that derivative for x, right? So lambda a exponential lambda x. And what about y double prime? Means second derivative for x, lambda square a exponential lambda x. Now we can substitute these guys to the original equation, Alright, so if we do that, what is it? Equation means lambda square a exponential lambda x minus 5 lambda a exponential lambda x and plus 6a exponential lambda x equal to 0. Right, so we can rewrite a exponential lambda x lambda square minus 5 lambda plus 6 equal to 0, right? From here, this guy is not equal to 0, so to get the 0, this guy should be a 0, right? So lambda square minus 5 lambda plus 6 equal to 0, right? So 2, 3 minus minus, so we can rewrite lambda minus 2 lambda minus 3 equal to 0, right? So lambda 1 is equal to 3 and lambda 2 equal to 2, right? So we can find the value of the lambda, so we can substitute this kind of lambda to the y, right? So what about y1 equal to a1 exponential lambda 1x, right? So a1 exponential, what is lambda 1 is 3, right? 3x. And y2 equal to a2 exponential lambda 2x equal to a2, what about lambda 2 equal to 2, right? Exponential 2x, right? So we can sum the value, the answer of the y1, y2. Why? By principle superposition. Principle of superposition. We can use principle of superposition because this system is linear, right? This equation is not linear, just linear equation. So we can use the principle of the superposition. So what is y1? y1 is a1 exponential lambda 1x and plus a2 exponential lambda 2x, right? So a1 exponential 3x and plus a2 exponential 2x, right? So y equal to a1 exponential 3x plus a2 exponential 2x. Here's my answer. Very straightforward and very easy, right? With the constant of the coefficients. Okay, thank you.